All right. Last time we talked about the sum and difference rule. If I have y equals, what's I going to do? 5x squared plus 2x cubed. Nicely, we have the sum rule there. What's going to be the derivative? Well, it's 10, right? X to the first, because I bring down the power, so it'll be 5 times 2, and then subtract 1 from the power. This one will be 6x squared, right? Or if y equals 5x squared minus 2x cubed, same thing. Derivative is 10x to the first minus 6x squared. Well, the thing of it is, if I have, though, 5x squared times 2x cubed, the same thing does not apply. In other words, I can't do this y prime does not equal the derivative of 5x squared, which is 10x to the first, times the derivative of 2x squared, 2x cubed, which is 6x squared. The derivative does not equal that. And I can prove that to you here because really, isn't this y equals 10x to the fifth? And I know, right, because 5 times 2 is 10, x squared, x to the third, that's x to the fifth. You add the exponent. I know that the derivative of that is, what's the derivative of that? 50x to the fourth. Bring down the power, 10 times 5. Take 1 from the power. The derivative there is 50x to the fourth, whereas this gives me, what does this give me? 10 times 6 is 60. X to the first, x to the second is x to the third. That's not the derivative, you see. So unfortunately, yeah, when you add, you just do the derivatives separately. Subtract, you do the derivatives separately. But when you multiply, you can't do those derivatives separately and just multiply them together. Doesn't work. And that's a real good example to show you that it doesn't work, okay? Well, let me do a little bit of notation. Of course, this is the sum rule. This is the difference rule. The sum rule, we can kind of write it like this. See if you're, they kind of do an kind of alternate way on the book. But the sum rule says, yeah, if you got y equals f plus g, then the derivative is just f prime plus g prime. Just do the derivatives separately. The difference rule says, well, if you got the difference of two things, the derivative is just the difference of the derivatives. Okay? Like I said, the book kind of does it differently, but you see what we're doing? Well, it turns out the product rule we just showed here, an example, the product rule is not, if we've got y equals f times g, two functions multiplied, the product rule is not f prime times g prime. Turns out there's a little more to it. It goes like this. Let's try, for the product, try this. Let's do f times g prime plus g times f prime. Seems a long way to go at it, but sometimes you have to do this. We didn't really have to do it on this one, but let me just show you that it works for this one. All right, so let's back up. We know what it should be, the derivative. Let's see if this works. Here's what it means. If this is f, this is g, then the derivative, it says, I do, well, let me recopy. It's f times g prime plus g times f prime, and we'll talk about maybe how to remember that a little better, but that is one way to write it. All right, so this just means take f, which is 5x squared, times the derivative of g, which, so yeah, I'm going to do the derivative of that one. The derivative of that one would be the 6x squared, right? Then I take the g, don't do the derivative of it, just g, so that would be 2x cubed times the derivative of f, which is the 10x. And I know this is a roundabout way of doing this one, but just to show you that it works. All right, so this is y prime equals, that would be 30x to the fourth, right? 5 times 6, x squared, and that would be 20x to the fourth, which, that's like terms, which is 50x to the fourth, which is what we knew it should be. Okay. Now, I realize here, this is definitely the way you'd want to do this one, but there are times when you'll have to do them like this, and I'll give you a for instance right here. But it does work. Now, as far as remembering it the way I like to remember it, for the product rule, let's call this one the first, this one the second. Okay? So if you have the first function times the second function, what it is, you've got the first times the derivative of the second, d of the second, plus the second times the derivative d of the first. So you're just kind of rotating it. First times the derivative of the second plus second times the derivative of the first, or vice versa. You could do the second, you know, or do the derivative of the first times the second. Okay? With me on that. So just rotate it. Rotate it around to do the product rule. All right, now let me show you a good example, a couple of examples of where this goes comes into play. So that's our product rule. These first two, there's different ways you could do it, but let's use the product rule, and that's what I want you to do on this homework. Be sure to use the product rule here. All right, so let's say we've got a function f of x equals the cube root of x times x squared minus 5x plus 4. So let's use the product rule on that. Right, because we do have a product there. This times that. So this is my f, this is my g, or that's my first, that's my second, however you want to. And so the, I'll use the product rule to find the derivative. So f prime here is going to be, the way it works is you do the first, this is one way to do it, the first times the derivative of the second. So I do the derivative of this one. First, what's the derivative of that one? Well, that one's a nice derivative because it's just minus and plus, so I just do the derivative of x squared, which is, what's the derivative of x squared? X to the first, bring down the power though, so it'll be 2x. Derivative of that, minus 5x, what's the derivative of minus 5x? Just minus 5, x to the 0, so you don't need that. What's the derivative of 4? Derivative of a constant is 0. So it's just 2x minus 5. All right, plus then, what do we do for the second part? Well, then we do the second one, the g, x squared minus 5x plus 4 times the derivative of the first one, which is the cube root of x, which is, how would I write that? Think about that to do the derivative. X to the 1/3 power, yeah. Cube root 1/3 power. So what's the derivative of x to the 1/3 power? Well, bring down the power, it'd be 1/3 x, and the new power would be 1/3 minus 1, which is 1/3 minus 3/3, it's negative 2/3. Okay, there's ways you can clean that up. We could multiply that out, but not a whole lot Not a whole lot of cleaning up. That one will do. I don't think. No. Okay. All right. Okay, let's do the same thing. Say we've got g of m equals to 3m to the 5th minus 9 times 7m to the 3rd minus 8m squared plus 5. Again, use the product rule to find g prime. This one, there is another way. We'll talk about that in just a second. But g prime of m, that equals. So by the product rule, what do? Well, there's two parts. The way I do it, first, don't do the derivative of the first, just 3m to the 5th minus 9, straight up, times then the derivative of the second. Well, the derivative of the second, we got 7m cubed, so that would be, bring down the powers to be 21m to the second, subtract 1 from the power. Right here it would be minus, that would be 16m to the first, or just 16m. Derivative of the constant is 0, so it's just 21m squared minus 16m for the derivative. Plus then the then you take the second, 7m cubed minus 8m squared plus 5. So I just wrote the second one straight up, times the derivative of the first, which would be, the derivative of that would be, 15, bring down the power, multiply by 3, 15m to the 4th. And then what about that? 0, it's a constant. There you go. Okay? So that would be one form of the answer. Now, in the back, here's what they would do. Because this is going to have some like terms, we can go ahead and multiply these out, foil these out, foil this out. So that would be what? 63 m to the 7th minus 48 m to the 6th minus be 189 m squared plus 164m, I believe. No, 144m, sorry. 16 times 9 is 144. And then over here, multiply those, so you'd have 105, 7 times 15, m to the 7th, 15 times 8, 120, so it'd be minus 120, m to the 6th, plus 75, m to the 4th. So we wind up with like terms here. I've got m to the 7ths, 168 m to the 7th, m to the 6th. So we got minus 168 m to the 6th, m squared. It's only 1. M, that's only 1. M to the 4th, that's the only one. Okay. So there's my derivative. So anyway, that's using the product rule to get that. Now, both of these really, we could have done another way. Do you see another way we could have done both of these? Couldn't I have on this one go ahead and distribute that in? And if I distribute it in, I'm adding some powers and things like that, but I'd get a little different answer on that one. And this one, we could multiply these two things together and then do the derivative, because then it's just sums and differences. But you will need the product rule. And let me show you one where you'll have to use the product rule on. One like this. I need to tell you, we'll talk more about it next time to do this one. I need to tell you that if you've got the sine of x Turns out the derivative is cosine x. Like I said, I'll explain that more why later on. But here's what I want to do. Let's say I've got f of x equals, you with me on that? The sine of x, the derivative turns out to be the cosine. We'll explain that more next time, but for now. Sort of, yes. But here is the one I was going to do was 10x cubed, f of x equals 10x cubed times sine of x. It's very tempting here to say the derivative is 30x squared times the derivative of sine is cosine. But is that right? Is the derivative 30x squared times the cosine? I mean, the derivative of that is 30x squared. The derivative of that is... Why is that not it, though? Because this is a what? It's a product, right? So, what do we have to use? You have to use the product rule. And this is one where you have to use it. You can't get around. There's no little trick to get around it. I mean, you can do, well, I guess of course you will. But this is a product, so you have to use the product rule for derivative. The derivative here, how's the product rule go? One way to think of it is just take the first, then times the derivative of the second. Well, the derivative of sine is cosine. Plus then the second, which is sine, times the derivative of the first, which is the 30x squared. That's the correct derivative right there. Okay? So there are times where you can't get around using that product rule like we could have on those other two, but this one you can't. You got to use the product rule to get the correct derivative. With me? I wanted to show you that. One other I didn't mention, but you know that product rule, I showed you it worked on that one, but to get the correct one. But you can get the product rule from the limit definition. It takes a little trick. I think you have to add in and subtract like a special little thing, but you can get this the product rule that I had there. You can get that from the limit definition. These all do come, and they probably have it in the book if you're interested in that.